Okay, continuing with 5.1, a definition or a term that you need to know is a corollary. And you always take a corollary to a theorem. So a corollary is just a statement that directly follows a theorem, or it's a statement that can easily be proven by a theorem. So a corollary, similar to a theorem or a postulate, they're numbered, they're named as well, and then don't worry about the numbers as much as the name, and then specifically what a corollary states, and then how to be able to apply it. But corollary 5.1 is the corollary to the triangle angle sum theorem. It states this: the acute angles of a right triangle are complementary. So here's my right triangle, triangle ABC, and then the acute angles of the right triangle would be angles A and angles B. And if they're complementary, that means the measure of angle A plus a measure of angle B is equal to 90 degrees. The reason why that's a corollary, it directly follows the triangle angle sum theorem, or it could be proven using the triangle angle sum theorem, because the triangle angle sum theorem states all three of the angles, so the measure of angle A plus a measure of angle B plus a measure of angle C of a triangle equal 180 degrees. You know the measure of angle C is 90 degrees, so I could substitute that into this statement. And then if I subtract 90 from each side, that gives me this statement right here. The acute angles, angles A and angle B of the right triangle are complementary. So that's the corollary to the triangle angle sum theorem. And we'll take a look at it, some examples from 5.1. Okay, so for the first few examples here, it says classify the triangle by its sides and by measuring its angles. So I could use a protractor to measure the angles. I'm just going to kind of eyeball some things here. So on number 1, if I look at side length RQ, PQ, and then PR, all of those are of different side lengths. So this is a scalene triangle. And then by measuring its angles, angle R is an acute angle, angle P is an acute angle, angle Q is what's most important here. That's an obtuse angle, so it's a scalene obtuse triangle. It has an obtuse angle. And then on number 2, again, all the side lengths are different length. Angle C is a right angle, so it would be a scalene right triangle. And then on number 3, EG and FG are congruent. So it's an isosceles triangle. And then for the angles, angles E, F, and G are all acute angles. So it's an isosceles acute angle. And then on number 4, without actually doing that entire problem, I'll just describe how you can go through and figure out the type of triangle it is. By its sides, I could graph this and then find the length of side AB, side BC, and then side AC as well. You don't even have to graph it. You could use the distance formula to find the distance between points A and B. That would be the length of side AB, and so on. And then if any two sides are congruent, it would be isosceles. If all three sides are congruent, then it would be equilateral. If none of these sides are congruent, it would be scalene. And then it says determine whether it's a right triangle. So what you could do either on your graph or just using the equation or formula for slope, you could find the slope of side AB, slope of side BC, and the slope of side AC. For example, just to find the slope of one side, side AC. I'm going to let this be x sub 1, y sub 1, and this be x sub 2, y sub 2. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Negative 4 over negative 4, the slope is 1. And then you could repeat the process for sides AB and sides BC. If it's a right triangle, then two of those sides should be perpendicular, which means they should have the opposite reciprocal slope. So if two sides have the opposite reciprocal slope, then it is a right triangle. Okay, and then on examples 5 and 6, find the measure of the exterior angle. So if you remember the exterior angle theorem, here's an exterior angle, angle 1. The measure of an exterior angle is equal to the sum of its remote interior angles. Notice I'm not given the measure of the adjacent angle that's interior to angle 1, because although you can find that using the triangle angle sum theorem, the measure of this exterior angle, so the measure of angle 1 is equal to the sum of its remote interior angles. These are the interior angles that are not adjacent to angle 1, so it's 53 degrees plus 53 degrees, where the measure of angle 1 is 106 degrees. That's the shortest and possibly the easiest way to do that. You could find the measure of this angle by adding the 53 and 53, still 106, subtracting that from 180 to get the measure of this interior angle. And then these two angles form a linear pair. You still would get the exact same measure for the measure of angle 1. And then number 6 is similar, except now you're given algebraic expressions. This is your exterior angle, 8x minus 5. It's equal to the sum of its remote interior angles. 40 plus, and then I'm just going to get rid of the parentheses here for this remote interior angle. This 5x plus 15 is actually this angle right here, 5x plus 15. And then without going through the work, you could find the value of x by solving that equation. I would think you'd be able to do that without too much difficulty, but following the directions, a measure of the exterior angle. Once you find the measure of x or value of x, then you substitute it back in to find the measure of this angle. Maybe take a couple minutes. I said I'm not going to go through that, but I'll go through the work and you can see if you have your correct solution. Okay, so you can see my work. Solving the equation for x, first of all, x is equal to 20, and then substituting that back into algebraic expression in order to find the measure of the exterior angle. Sorry, let me try to get a better focus there. The measure of the exterior angle is 155 degrees.